Okay, so today I want to look at adding and subtracting surds, and that's the what, that's what we're doing. The reason why we're doing this is we're starting to see what operations will work with surds. We're starting to see what uses we may be able to have for surds. So, what I want to go back and recall some of your algebra. I want to recall the rule in algebra that says you can only add or subtract like terms. So for example, if you say 6a plus 2b minus a, we can only add and subtract the like terms. So we end up with 6a minus a plus 2b, which is equal to 5a plus 2b. So we've done that in algebra before. Now the same rule applies with surds. We can only add and subtract like surds. Now what like surds are those with the same surd part. So for instance, if I have the square root of 3, if I have 2 square root of 3, if I have negative root 3, they've got the same surd part. They're like surds. So another set of like surds, different to this set, 2 root 7, 7 root 7, root 7. Again, they've got the same surd part. So they're like surds, and they're the only ones we can operate on by adding and subtracting. So if we've been asked something like this, simplify this expression. So simplify in this case means add it up. We can only add and subtract the like surds. I've got root 2, root 5, root 2. Only these two can be added and subtracted. So root 2 plus 3 root 2 I can do, but the root 5 is on its own over here and I can't do anything further with it. Now this is the same as 1 root 2 plus 3 root 2. I get 4 root 2 plus root 5. So it's very much like algebra. I'm only dealing with those that are like. If there's no number out the front, it means one of them. So when I have something like this, then again I need to collect my like terms, just like I would in algebra. I look at it and say I've got this and I've got this. The negative sign belongs to the term that's off to its right. So I'd rewrite it as negative 2 root 5 minus 3 root 5. That's that set of like terms. I have this set of like surds here as well. So I have a plus 4 root 3 and a minus 5 root 3. And then I'll do these as two separate sums. Negative 2 take away 3, negative 5 root 5, 4 take away 5, negative root 3. And that way, again, only like surds may be added and subtracted. I stop at that point, I have my answer. Now sometimes it may not be obvious we can straight away work with our surds. Root 20 plus root 80, we might be thinking, not like surds, don't touch them. But in fact here, what we should do is say, can we simplify these? Can we apply what we learnt the last lesson and express them as the product of two numbers, one of which is a perfect square? So you think of the perfect squares that go into 20. 4 is one of them, times 5. The perfect squares that go into 80, this one may take a little bit more of your brain power, but you could just check them back from half of 80 backwards. You'll get 16 is one of them, and it goes in 5 times. So what I end up with here is the square root of 4 times the square root of 5 plus the square root of 16 times the square root of 5. And hopefully you can start to see that what's developing here is like surds. Both of these have square root of 5. Adding them together gives me 6 root 5. Okay, as your proof of homework, I want you to spot the mistake in the working out I'm about to do. I've got 3 surds, none of them look alike, so I'm going to check quickly if I can simplify them. Square root of 54, looking for a perfect square that goes into 54, I'd be thinking of my factors of 54, 9 times 6. Square root of 27, looking for the perfect square that goes into 27, 9 times 3. 9 is a perfect square, goes into both of them, minus root 6. I keep my simplification going. I say it's the square root of 9 times the square root of 6, plus the square root of 9 times the square root of 3, minus the square root of 6. So I get 3 root 6 plus 3 root 3 minus root 6. I collect my like terms together. I simplify this section down and end up with 3 plus 3 root 3. So, have a look at that. I'll call this one line 1, line 2, line 3, 4, 5. Which line is the mistake in and what was it? Add it to the comments page on the website.